Now we're going to look at a process known as hydrohalogenation. And this is our first addition process where we're looking at adding a molecule that has two different atoms, a hydrogen and a halogen. So when we add this HBr or HCl across an alkene, we're still going to get single bonds as our product, but one carbon in the double bond will be singly bonded to the hydrogen, and the other carbon will be singly bonded to the halogen, whether that's bromine or chlorine. So let's look in more detail at an actual reaction, and let's consider HBr adding to 2-methylpropene. So when we look at this addition process, there are going to be actually two potential products. In one of the products, this hydrogen and the HBr could add to the carbon on the left to form a single bond with it, and the bromine and the HBr could bond to the carbon on the right to form a single bond with it. And as it turns out, we see very, very little of that product. Instead, what we see is a preference for this hydrogen in the HBr to react with the carbon on the right in this double bond, which already is bonded to two hydrogen atoms, and the bromine in the HBr to preferentially bond to the carbon on the left, which is bonded to two methyl groups. So the primary product we form from the hydrohalogenation of 2-methylpropene is 2-bromo-2-methylpropane. So how are you going to figure out what product is going to be predominant? And you will be expected to determine that. So how do you figure that out? Well, you're going to apply what's known as Markovnikov's rule. And the way that Markovnikov's rule works is that when a molecule that has hydrogen and some different components, such as HBr or HCl, adds across a double bond, the hydrogen in that small molecule that's adding across the double bond, that hydrogen will preferentially bond to the carbon in the double bond that already has more hydrogens. So if we look at 2-methylpropene, the carbon on the right has two hydrogens. So this hydrogen in HBr is going to preferentially bond to that carbon, and the bromine will bond to the carbon that has less hydrogen. So you will be expected to look at the structure of any alkene that an HBr or HCl is adding to, and know that the hydrogen from that small molecule is going to bond preferentially to the carbon in the double bond that already has more hydrogen. Now, sometimes we'll do hydrohalogenation, but the alkene, the carbons in the alkene bond will have the same number of hydrogens. So that's the case in 2-pentene. If we look at these two carbons in this double bond, each only has one hydrogen. So if that is the case, then we will have an equal mixture of both potential products. So what are the potential products? Well, one of the potential products, if we add HBr across the double bond, is that hydrogen will bond to the 2 carbon and bromine will bond to the 3 carbon, and our product will be 3-bromopentane. The other possibility is hydrogen will add to the 3 carbon and bromine will add to the 2 carbon, and that possibility is 2-bromopentane. So Markovnikov's rule applies across a double bond, and the hydrogen in the small molecule that we're adding, in this case HBr or HCl, this hydrogen will preferentially add to the carbon that has more hydrogens. If each carbon has the same number of hydrogens, then we'll have a 50-50 mixture of both potential products.